So 1.4, we're going to be talking about absolute value expressions and equations. Like I said, we're skipping 1.3. You made it to honors, so that probably means you know how to solve an equation. If you need help solving equations still, we're going to get lots of practice at it in this section. In 1.5, solving inequalities, and then in 1.6, solving compound inequalities and absolute value inequalities. You're going to get lots of practice, so I didn't feel like we need to practice solving equations in isolation. Okay? So the first thing we need to be on the same page about is what absolute value is. Okay? The definition is the absolute value is the distance from 0 on a number line. We say that the distance is always non-negative. The reason that we don't say that the absolute value is always positive is because sometimes it can equal 0. But the absolute value always produces a positive and 0. That's what non-negative means. Absolute value can never produce a negative distance. I mean, there's no such thing as a negative distance. If you're trying to figure out how far it is from here to your house, that distance is the same if you're going from here to your house or from your house to here. The distance is the same regardless of which direction you are going. Now, sometimes we'll indicate distance with a negative to indicate direction, but we're talking about on a number line. We're talking about taking a tape measure, so to speak, and making that distance, and the direction won't change how far away it is. That's really what the absolute value is. The absolute value has these symbols, these sort of long, straight lines. And those long, straight lines are grouping symbols. And they kind of resemble and operate like parentheses do. So, if you remember your order of operation, you are going to have to do what's in the absolute values first, even though absolute value is not on PEMDAS, which I'll get into why I don't like PEMDAS here in a second. Okay? So I'm going to give you a couple quick examples. Okay? The absolute value of -5 equals +5. Again, the output is non-negative, because -5 is 5 units away from 0. What other value besides -5 will produce +5? Absolute value of what else will give me 5? Xavier? 5. So 5 is also 5 units away from 0. So there's two different ways to get +5 out of an absolute value. One is -5, one is +5. In the same way, +3, the absolute value of +3 is equal to 3. Again, it keeps kicking out non-negatives or positives. An absolute value can never produce a negative. The output value of an absolute value can never be a negative. That is not a possibility. Here's where your note-taking skills need to kind of develop a little bit. If you notice here, everything is exactly the same except the numbers. So instead of writing it out word for word again, come up with some system that allows you to basically rewrite the same thing but change the numbers. Right? Because taking that time to do all that writing is just not that necessary. It's the same thing. Okay? Copy-paste works. And Notability is perfect. Oh, that reminds me. And I don't think there's anybody here that does it, but we don't do notes on paper, none of you are, and we don't do homework on paper. It's all on the iPad, okay? I realized I hadn't actually said that out loud yet, so I wanted to make sure you got that.
You did on the first.
I never said that.
Absolutely.
All right, let's look at an example. Evaluate. This means I have an algebraic expression. An algebraic expression is part of an equation. Please don't turn this into an equation. You know, when we have an equation, we have the left-hand side of an equation and the right-hand side of the equation. An algebraic expression It's just either that left or right hand side. No equals to something else. Now, I know that seems contradictory when you see this thing over here. The expression is this. Whenever you see the word evaluate, that means plug and chug. Okay? So, go ahead and do this. Compare it to somebody near you when you are done. Now, here's the thing. It is imperative that you show all your work, even if it's easy. I'm telling you, the whole point is for me to make sure you're thinking the right way in order to get the right answer. Getting the right answer is not the point. It's the thinking that's super important. That way I can help you if your thinking is off. But if all I see is an answer, I can't help you if you mess up. And I have no idea how you arrived at that answer. Maybe you were using a calculator, and we're not supposed to be using calculators. So, show me the work. So, the first thing I should do is substitute in for x. And x is 4. Now, I'm going to mention this again about the absolute value and parentheses and that kind of thing. Now we've got to follow order of operations. Okay? This is why I don't like PEMDAS, because there are no parentheses. Well, I put a parentheses here, and there's nothing to do inside there. But you have to do what's inside the absolute value first.
Oh, okay.
Okay? The absolute value is a grouping symbol. It should be a G, it should be GEMDAS, not PEMDAS. Okay? Because it's a grouping symbol. You've got parentheses, you've got absolute value, you've got brackets, you have braces, you have a fraction bar. Okay? Those things are all grouping symbols that separate parts of an expression, and you need to do those parts first. So, inside here, if you went 6 minus 2 first, you hit the gas when you came across a red octagon while you're driving. You can't do subtraction first. Don't make up your own rules. What do you have to do first?
Multiplication.
Multiplication, right here. So you should have had the absolute value of 6 minus 8. Now, another thing that you want to do with the absolute value is keep going inside there as far as you can. Finish it. What's 6 minus 8?
Negative
2. Okay. So the absolute value of negative 2 is going to produce a what?
Positive.
Positive 2. So I got 4.7 should be my final answer. How many had that?
I did.
Okay, good. Let's get into equations a little bit. Are there any questions before we do that?
That was hard.
So, one other thing I want to mention before we get there. Notice here that I kind of funneled down to my answer.
Here.
Please do that. Okay? Don't all of a sudden go horizontal and throw an equal sign in there. There is no equation here. It is an expression. It stays an expression. Don't give me the, I'm running out of room. You have an unlimited supply of paper. There's no running out of room. Okay? If you're worried about the space you're taking up, like you're just not paying attention to the device that you have in front of you. You have an unlimited supply of paper. Don't worry about taking up the space. There's plenty of space. All right. This is imperative. You must do this first, and I'll explain why here in a minute. When solving absolute value equations, get the absolute value alone first before you do anything. Get that absolute value by itself. Now, some of them it'll already be by itself and you'll be in good shape. But there's going to be ones, like the example I'm about to show you, where that is not the case. And I'm going to explain why it's important here in a second. So here's the thing with this. I'm just going to be honest with you. There are times where you will be able to get the correct answers without doing this. But there are other times where it's not possible. So, if you just do this every time, you'll be in good shape. Some of you will still forget. I'm telling you right now. On your test next week, some of you are still going to forget. Even though I've underlined it, put it in all caps, am emphasizing it right now.
Put an exclamation mark too.
Put an I yelled it, like I extra yelled it with the exclamation mark and the all caps, and some of you are still going to forget. And my hope is that by being ahead of it that maybe you won't actually forget, and I'll be wrong, which would be fantastic. All right, so here's the reason why we have to get the absolute value first by itself. It is possible that there are no solutions to an absolute value equation. It is possible that there is one solution to an absolute value equation, and it is possible that there are two solutions. And until you work with these a little bit, and until you get the absolute value by itself, you're not going to know if it's 0, 1, or 2. And by getting that absolute value alone first, it's going to be easier to identify how many solutions there should be, so that when you're finished with the problem, you can feel confident that you've done it correctly. Okay? So I'm going to give you some real simple examples, and we talked about this a little bit on the first slide, but I'm going to talk about it more in-depthly now. Here's an example. The absolute value of x equals 4. That is an absolute value equation. The absolute value is by itself on one side. What values of x will produce a positive 4? Negative 4 or positive 4. Okay, so this is a two-solution situation. Okay, x could equal 4 or it could equal negative 4. In either case, when it's in here, it will produce positive 4. So there's two solutions there. Okay. How can I only get one solution?
I don't know, man.
Any ideas?
0.
0.
X is equal to
Correct.
negative.
See, absolute value of x equals 0. Because in your mind, you're like, wait, no, it's 0 and negative. Oh, that's the same thing. There's no such thing as negative 0. Okay? In a situation like this, that's where you're going to get your one solution, x equals 0. Or if the absolute value equals 0.
I'm so smart.
All right, Connor, let's hear it.
X equals negative 4.
Negative anything, right? The absolute value of x can't ever equal a negative. I'd put negative 8.
8.
So long as it equals, the absolute value is by itself and it equals a negative, that's not possible. We can't have that. The absolute value can never produce a negative. I mean, go off the definition, it's non-negative. So if all of a sudden you're in a situation where you have the absolute value by itself equals a negative, that means there are no solutions.
Can you just write the little symbol?
Yes, you can write the empty set symbol to indicate no solution if you wish.
I'm smart.
Now, because there are these three possibilities, here's what you're going to have to do every single time you have an absolute value equation. You have to check your solutions. Even if the directions don't say to check, you have to check them. Because what can happen sometimes is you produce what is sometimes called false solutions. You go through all the steps, the algebra works out, and you get this number, and the reality is it actually doesn't work. And you're going to see when we get into quadratics and cubics that happens sometimes. Okay? So, every time, whether it's in the directions or not, solutions must be checked. On your test, if you have an absolute value equation and you don't check the work, you won't get full credit. Okay? It just has to be understood. We all have to have that same understanding. Absolute value equations, you got to check your answers. Okay? Got it? All right, let's look at an example. Here's an example. Now, in this one, I was kind enough to put solve and check. What do I have to do first?
Get the absolute value.
Get the absolute value by itself, which means in this particular problem, I have to do what?
Subtract.
Okay, so let's just understand something here. The absolute value is here, but I have a plus 3 on that side with it. I need this absolute value by itself, which means I need to get rid of this plus 3. How do I get rid of it? What property is that?
Subtraction.
No. What are we actually doing when we get rid of it? What are we doing to the
Discard.
turning it into?
Flip it. Additive inverse.
Additive.
Right. It's additive inverse. We're turning the plus 3 into a 0,
You gotta redo that.
right? We do it to both sides. Now obviously that changes the right hand side too, but positive 3 minus 3 is 0. That's the additive inverse property. And we do that. It's also the subtraction property of equality. It's called lots of different things. But the idea is we're turning it into a 0 to make it go away. And I can't just erase it. I have to balance that equation out. Now I have the absolute value by itself. Okay, so this goes back to the other problem. So what I've highlighted in green, that can be equal to what? 2x plus 7 can equal what?
30 or 44.
No.
Wait, never mind. I think
Yeah.
that's different.
It can equal 37. The absolute value inside of that can equal positive 37, or inside of that can equal negative 37, which means I'm going to have two equations that I need to solve. This is why getting the absolute value by itself is important, because what's inside here, and I said what's inside there like it was just a plain old x, like we did on the previous slide. If what's in green equals 37, the absolute value will be positive 37. If what's in green equals negative 37, the absolute value will also be positive 37. So go ahead and solve those. Here's the thing. When it says check, that means yes, you have to show the check. Okay? Again, in order to show the check, you have to write it all out. So let's go through the steps here. First of all, on this one I subtract 7, 2x equals 30, divide by 2, x equals 15, but you're not done. Now you got to do the check. When you check using the original equation. So I've got to go back up to the top, and all I do is take 15 and substitute it back in for the x. Now, here's what that's going to look like. So I've got 2, and I'm going to put 15 in a different color, plus 7 in absolute value, plus 3. Now here's a symbol you've probably not seen before. A question mark on top of an equal sign. Because what we're trying to do is, does the left-hand side equal 40? And that's what the question mark means. Does it equal?
You're showing.
Okay. So this is the absolute value of 37 plus 3. That's 37 plus 3. That does equal 40. I'm in good shape. So that one checks, and now I can circle it. Okay?
The other one checks too.
Alright. So now we do the same thing on the right. I subtract 7, 2x equals negative 44. Divide both sides by 2, x equals negative 22. Now I just have to make sure that that actually works. So again, I go back to the original problem. I plug negative 22 in for x. And we're trying to see, does this equal 40? So this is the absolute value of negative 44 plus 7 plus 3. That's the absolute value of negative 37. That's 37 plus 3. It does equal 40. This one also checks, and we're good. So, on your test, in your homework, whether the directions say it or not, you have to show the check. I'm telling you, sometimes you will find answers that don't work. And it's one of two reasons. One, you're dealing with creating extra solutions that weren't there to begin with. You're dealing with quadratics, cubics, that kind of thing. Or you didn't get the absolute value alone by itself first. So what can happen is you figure out whether or not you did it right. And it's important that you plug it into the original equation, because as soon as you start manipulating the equation, if you try to plug it in somewhere else and maybe you messed something up a little bit, then it's going to confirm that what you did is right, even though you'd already messed something up. So you got to plug it in the original one. I don't want you to get sort of a false sense of hope if you didn't do it correctly. Question? No?
Yes, I have a question.
Yeah.
So, like at the top there,
Mm-hmm.
when you take through from both sides,
Yep.
you actually have to show that you're taking through from both sides.
You're in Algebra 2 honors. It wouldn't surprise me if you could get from here to here. In fact, that shouldn't be hard at all. Again, but here's the thing. Let's say you mess something up, and it's on a test, and you skip that step, and you write a 38 here.
Yeah.
How do I know where that came from? The more work you show, and I'm not going to try to guess what you were thinking. I'm never going to do that. The more you show me, the easier it is for me to determine what you were thinking. Okay? So, when in doubt, show more than not enough. Okay? Any other questions?